All right, start the recording. Welcome, everybody. Today is Saturday, February 19th in Dallas, at least. It's the Dallas Personal Robotics Group monthly meeting. Today, we're going to have a presentation by Jack Jones on his journey to build a pretty fancy robot that he's done over the years. Briefly about DPRG, it's founded in '84. It's an iOS 501c educational focused organization. You can join us online every Tuesday night, and then generally every second Saturday of the month, of each month. This month we're on the 3rd, and we're all about building robots and mechatronics and software and all the things it takes to pull such things together. Shout out of thanks to our supporters. These are various groups that have supported DPRG, at least in the past. There is a Discord server that someone who's a regular for a couple years sparked up, but due to another job, and he lives in New Zealand, Murray is unable to join on a regular basis. But if you're at all interested in a more interactive Discord style thing, ask, and we can put a fresh invitation in the chat. Today we'll have Jack Jones' presentation. We were supposed to have a 2-part annual meeting, but we're still pending someone to volunteer to run as the next president. So I've exhausted the term limits, so I'm just kind of being a good guy and acting as interim. There are a handful of upcoming topics for potential monthly meetings with some people penciled in. So if those folks pull their stuff together and want to present, I can organize it. But otherwise, I'm not going to actively go chase down monthly meetings coming up just yet. Any question on this stuff so far? All right. So we have a couple of things, some recognition and awards. I was holding off for the annual meeting to show these. The first one is a shout out of appreciation from Iron Rain. This one came in last July, and I can skim through it here. Basically, it's Team 6832. They wanted to thank us for as DPRG in supporting them in last year's competition season. We reviewed their presentations and helped them create ballistic equation sets to optimize their launcher. They called it the Ring Slinger. I think we had some fun discussions to help them name it as well. Especially with the pandemic, they really appreciated our help and mentoring. And they said, thanks to our efforts at DPRG, they were able to optimize the robots to a level they'd never seen before. And they earned finalists for the Think Award, which is a really top award in that competition series for excellence in engineering documentation and developing the robot. And had it not been for the pandemic, they would have advanced to the World Championship for the 4th year in a row. So anyhow, they're given a very nice credit to DPRG, and it's really, I don't know about you all, but I find it really heartwarming to know that we can make a difference in these young folks' lives.
Woo!
Yeah. And then the next one, some few people might be aware of this, but the club would like to recognize one Doug Parody. So we have an award for excellence, 2021 award for excellence, Doug. So this is in recognition of long-term exceptional service to DPRG. How about a round of applause for Doug?
Well deserved there.
I'm telling you.
Here, 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 here.
So this is in special appreciation for maintaining countless items, and if you all haven't been an officer in the club, you don't have any idea as to how much Doug does. I can assure you of that. But he's just played a critical role in keeping things functional well. So that's a thanks for the club, Doug. Way to go!
Thank you, guys. Appreciate it.
By the way,
Appreciate it a lot.
Oh, is Doug Parody real? I thought he was just like software or something. I thought.
Doug, like the Golden Globe Awards, you want to have an acceptance speech?
What if there's a script running somewhere? Oh, I see. He's real. It's a human.
Plus AI.
That's very, I really appreciate it, guys. Thank you. And I've really enjoyed the club. It's given me a lot of things, especially in the pandemic here where, if it weren't for you guys, I'd probably, might as well be in the closet, because there's nothing else going on pretty much. So.
That's really true, Doug. And, I really think we've gotten to know each other better by doing these Zoom sessions.
I think so too, David. There's no question that it has been. I can't believe how well this I don't know what you want to call it, chat meeting has gone off in the 2 years that it's been going on. We would have never done it. We would have never done it if it wasn't for the pandemic. So this is truly one of those blessings that comes out of the pandemic. And, we've met a lot of people, and I'm really cool because, I'm hoping one of these days I can, I can get to actually go to some of these places. I actually went to within 23 miles of Murray's home just as he started to come to our meetings, because I had a trip down in New Zealand, and if, nowadays I would have definitely, asked him to come and have a lunch somewhere. So it would have been cool. And someday we'll get up and see Pat, up there in the Arctic Circle there. When Carl says, it was slightly chill here, he meant 64 degrees, Pat.
Yeah, today is about minus 12 Celsius, so that's not bad. It's a nice winter day.
Okay. Well, again,
but don't wait until Wednesday. Wednesday is when we're going to get cold.
Yeah.
Oh, can I ask a question?
Sure.
Will was trying to plug into the meeting without a camera. Can he do that if he goes?
Oh yeah, you don't need a camera.
Okay, that's what I thought.
You
So
should have a microphone though. I mean, all you have to, if he's not going to speak, all he has to do is have a
browser.
Yeah, browser.
A browser.
Yeah.
If he goes to the browser address and doesn't have, he should be able to just log in and see the browser. Okay.
Yep. And there's a chat window where he can type if he doesn't have a microphone hooked up.
Okay.
Yeah.
Or he could call me. Okay. All right. Okay. I'll talk to him about that. Okay. Thanks.
All right.
Okay. All right. And again, thanks guys. And I'm hoping we'll continue to go. I'm hoping we'll find us another president. I know Carl's been really good about being interim president now, but maybe somebody will step up. So let's go on that, and hopefully that'll happen. And hopefully, one of the things that we should put on our agenda to discuss is May. I think we might be able to actually have a competition in May. Even if we can't feel comfortable with an indoor one, we can probably have another outdoor one. So anyway, some things to think about. And thank you again.
Doug, I think for speaking for everyone in the club, it's fully well deserved, well earned, and hard earned. And so the order, I believe, dropped yesterday, and hopefully this should show up at your house around the 25th or so.
Hear, hear.
Way to go. One more. Thanks again, Doug. And with that, I would like to introduce our special guest, not a guest, he's a regular member, but our special presentator today, one Jack Jones. And Jack, with that, I'm going to go quiet.
All right. Thank you. And thank you for attending. I'm very glad to get this opportunity to do this. There we go. Can everyone see my screen? Hello? Yes? Okay. All right. So I've got a slide here that shows the outline of the presentation I'll be doing. I'll start out by just talking about what brought me to do the CoolBot and some of the things I did along the way. And then I'll be talking about the CoolBot itself, which was a cooler robot that was designed to sell drinks while following a sidewalk. I'll start within that. I'll be talking a bit about the initial idea, some sensor problems I encountered, a little bit of a divergence away from it, and then the sensor solution. And then finally, the completion and final tests of the robot. After that, I'll conclude the presentation by talking a bit about the Cracker Jack robot and the coffee robot, which I've worked on since the CoolBot has finished. If anyone has any questions, please feel free to jump in and ask them. I'd also like to, in particular, thank Carl for not only encouraging me to do this presentation, but also helping me to facilitate this presentation. And with that, I'll begin. So I got into robotics when I was in Ohio at about 6 years old, when I'd saved up to buy this toy R2-D2. And it was very advanced for the time. I'd give it verbal commands, and then it would either play tag or it'd search around the room all autonomously. And that really got me motivated and interested in robotics. And then I'd go to the library and I'd pick out all the books I could on robotics and learn as much as I could. And then my dad and I would build some kits. And eventually, in 2014 or 2013, I got into Arduinos when I moved to Texas. And this was my first, what I really consider my first real robot that I built, where I designed it to follow me using an infrared beacon. In this case, I had a TV remote. And I had 3 infrared sensors that would send a signal to the Arduino. And the Arduino would then read these 3 infrared sensors, and then based on the intensity level of them, it would figure out which direction the beacon was coming from, and send commands to the 2 H-bridge chips that I had controlling the 2 back motors. At the time, I didn't realize that 1 H-bridge chip can control 2 motors, so I thought I had to have these 2, but I quickly learned later that I didn't need to. Here's the video I've got of it. Let's play it. And this all finished pretty quickly. I think I got it done within like a couple months, and it seemed to work very well for the short amount of time. And I didn't realize that I would never complete a project that quickly again. But here's the after that, I wanted to add on this Pixie Cam, which had just recently come out, in order to I was thinking about maybe swapping the IR sensor out with this for tracking, but either way, I knew that I either wanted one or both, including this Pixie Cam. But this is where I really started to encounter a lot of problems. I could not figure out how to get this to work, and no matter what I searched on the internet, I could not get any help with that. And fortunately, by the grace of God, I was able to find DPRG, and I was very glad to see how helpful and kind everyone was, and that you all have been very patient with all my problems that I needed help with, and you all were able to help me to get this to work. So after after I was able to get it to track a color, I wanted to add on this robot arm kit that I had previously made. And here's a design of what I was intending. So I was going to have that mounted on top of the little robot that I already had, and then I'd have the Pixie Cam up top guiding it. And my plan was I wanted to have a laser pointer that I'd point at an object, and then the Pixie Cam would track the laser to that object, and then it would grab it, and then it would use these infrared sensors to return to me with since I had an infrared beacon on me. One problem I had though was it didn't have any encoders or any potentiometers on the arm so I had no clue of what the angle would be. So, and I didn't think it would be too necessary for me to know the exact angle. I just wanted to know that it wasn't going beyond the maximum angle. So I was going to add on little switches on each side of the joints so that I could know when it had reached its maximum angle. But the problem with that is it required a lot of wires connecting to all the switches. And at the time, I could only solder outside, and in the hot Texas summer heat, sometimes the joints would actually melt off when I was out there soldering. So I'd try to run outside, solder up the joints, and then run inside to the AC before anything fell off. But that would cause some problems. And then around 2015, I got my first 3D printer, and that was very helpful since I was now basically able to fabricate anything I could imagine for a very cheap price. And I also got the club robot, and I was going to use that as a base for I think I now named it the Cracker Jack robot instead of the little robot I previously had. However, it ended up becoming a pretty big mess of wires for multiple reasons. And I, around this time, realized what a lot of you all were trying to tell me with it wasn't the most ideal arm to be using for what I was intending to use it for. Partly due to, or actually largely due to the fact that it didn't have any encoders or potentiometers. And even if I could get it to grab an object without knowing its exact angle and operate with that, it would still be very limited to what exactly it could do. Also, the motors were pretty weak, and it could just barely lift the whole arm up, let alone be able to grab a large object and bring it to me. So I decided too that with the 3D printer, I could easily just print out a much better arm, and or even just buy a better arm instead. So I kind of set this to the side for a little while, and at this time, I also wanted to figure out a way of making this hobby be able to pay for itself. So I started making some designs. Needless to say, of course, the opposite ended up happening, and ended up being not paying for itself at all. And but I always wanted to make a sidewalk following robot, so I thought that could maybe be a good way of making a robot that could make money for me. And I also remembered going to my sister's golf tournaments, and they'd be very hot sometimes, and you'd always want to go back and grab a drink, but it'd be right in the middle of the tournament, so it wasn't the most ideal thing to do. So I thought I thought a golf course would be a good place to have a little robot driving around selling drinks. So this is what I intended with this design. I was going to have a custom cooler and some lights for just advertising. I had two main goals in mind with this project. I wanted it to be done in 3 months, and I also wanted it to be as cheap as possible. And in order to complete both of those goals, I decided on making simplicity the number one focus of this project. So I'd remove all the unnecessary things that I didn't need, and also some semi-unnecessary things. So for instance, I didn't have any refrigeration system. I was just going to use ice to keep it cool the whole time, since a refrigeration system would have been very expensive and also very time consuming for the project, and I definitely would not have been able to get that done in 3 months. And also I decided to use it on just the honor system instead of actually having it accept a payment and then dispense a drink, since I thought the golf course would be a pretty good place for that, and also it would be very complex and very expensive in order to put in a dispensing system, and especially if I was going to use credit card, it would be very difficult to have a credit card system, or I'd have to then have some cellular service in order to transfer the payment. So was just going to have this box here. I think it was maybe going to detect if I had put something, if someone had put something into the box. And then with that, it was going to use this linear actuator, which would raise the lid so that the person could grab a drink. As you can see, I crossed out the linear actuator, decided to get rid of that whole idea, and was just going to have it where it's just a box, and they could open up the lid themselves and grab the drink. I was going to have a webcam here, either for just recording it or so that I could maybe watch it live. I think I ruled the live idea out pretty quickly, and it's just going to have it to where it would record things. And then a ultrasonic sensor so that didn't bump into anything. And 2 color sensors I was going to have in order to follow the side of the path. I was going to use it kind of like a line following robot does, and I was going to have it recognize the color of the sidewalk, and then I was going to have the other color sensor recognize what wasn't the color of the sidewalk, and then based on that, it would steer itself along the edge. Here's a more refined version. This ended up looking more like the final version. I was gonna, instead of making a custom cooler, I was just gonna buy a standard one and build the robot around that. And I also removed the LED lights since I thought for a golf course that could be a little too distracting. I reduced the amount of ultrasonic sensors to just 1. I kept the color sensor idea, and then this time I settled on how I was going to have it drive. I was going to have a fixed rear wheel drive powered by a large DC motor that Doug had given me, and then I was going to use a servo to steer the cooler. And then I added on this flag just so that other golf carts could see it and not run into it, since it was a pretty small robot. But I ended up removing that since I thought at a golf course that could be pretty distracting and confusing. Here's a top view of it. I've got a menu here so that they could figure out what drinks there were and the prices, and then an LCD screen so that would instruct the customer how to purchase the drink. And then I was going to have it to where they'd first stop the robot with the stop button here, and then they'd open up the lid and grab a drink, and then they'd put the money into the box, and then when they were done, they'd push go. I ended up removing the LCD screen since I thought it was pretty unnecessary, and I could easily just put the instructions on the paper menu here. And I also removed the go button since I realized there was a good chance people were probably not going to push go and they'd just leave it sitting there. So, and I also realized that just having them push the stop button and delay it for a little while was pretty optimal, since I think I gave it 30 seconds, and that seemed like a perfect amount of time for them to easily grab a drink, pay for it, read the menu, and all of that. And it was also pretty slow, so I knew that if they wanted to, if it took off while they were still using it, they could easily just push stop again. After that, I started getting all the parts together for the robot. I decided to use this little red wagon for the base of the robot, and this ended up becoming the most iconic feature that everyone seemed to love. It was a really great base too. It was all metal. It was all metal, and it had a nice rubbery paint on it, so it didn't short anything. Except it did get pretty banged up later on, so some of the paint had stripped off and would fry some of the parts. But it also was had just the right amount of depth to where I could easily put all the parts in it, but yet not have too much room not take up too much room. And I also liked how the back wheels were already fixed wheels, and the front 2 wheels already had a nice pivoting system. So I easily just hooked up a servo to this little knob here and was able to easily steer. Here's the motor. It was hooked up with a belt to the back wheels here. I had a big gear there, and a servo the steering servo was right there. Here you can see I had all the electronics up front. At this time it was, I hadn't organized everything, but I did end up cleaning everything up later on. And I had the battery that would go back here, even though that isn't in the picture. So I quickly ruled out the idea of using the color sensors because I really underestimated how difficult it would be to follow a sidewalk outside. I had expected there to be some variability in the colors of the sidewalk, but I didn't expect them to be as large as they were with the mud and everything. And the if it rained, it would change the color of the sidewalk and the sunlight. I really didn't expect how large of a problem sunlight would be with everything. I didn't expect the shadows to drastically change the color that much for it. I was I had considered maybe for the sunlight, I was thinking about adding on a like some sort of cover over the color sensors to protect it from the sunlight, and then I just have my own artificial light being projected there. But that didn't wasn't an ideal thing either, since the pitch off the side of the sidewalk changed so much that I couldn't rely on that. And so after I realized the color sensors weren't going to work, I tried this Pixie Cam, and that showed some problems, or I mean, some progress compared to the color sensor, since it was able to recognize the sidewalk much better, since it wasn't just looking at a single point on the sidewalk. But it still wasn't ideal and wasn't very reliable. If there was mud, it would confuse it, and if there was sun shadows really didn't help it. It would get very mixed up with that. So around this time, oh, I did also try adding on a GPS. That I didn't realize it until after I got it how inaccurate your standard GPS was, and I didn't realize that there was a few feet error for the GPS, and that would easily accidentally send it off the sidewalk. And I looked into RTK GPSs, and that was too expensive of an option. I I know Ray's discussed some of that now, but I may if I decided to edit this project any further, I think I might try the RTK option again, but at the time it was too expensive when I was considering it. And I think Carl had mentioned the idea of using a cell phone, since cell phones, he said, use cellular service in order to help make the GPS more accurate. But the golf course that I had intended was way too, it didn't have really any cellular service at all, so that wouldn't have been optimal. And so around this time, I kind of considered giving up on the idea, since it was well over the 3-month goal, and the price was starting to get pretty expensive, especially with the options that I had to use. But really like the challenge of making a sidewalk falling robot, and everyone loved the little red wagon design that I had, so I decided to keep with it more as a proof of concept now rather than an actual way of making money. And I tried out this new J-Voy camera that I bought, and this was nice because it was way more advanced than the Pixie Cam, since it had a lot of features, one of which was nice for the CoolBot. It would track a path. So, but the problem was it was very hard to integrate with the Arduino. And when I finally did get it integrated with the Arduino, had a very bad refresh rate. As a result, it would end up almost going off the path, and many times it would go off the path. And also, for some reason, the servos were glitchy when it would work with this. I don't know what was causing that. If it was how I had it communicating with the camera, or if it was just the camera itself and its refresh rate. I'm not sure why that was a problem, but along that time, as I was trying to get that camera to work, I worked on some other projects. one of which was this Nixie clock that I made. I used these old Soviet bulbs for the clock, and I had it connected to Alexa so that it would cut off the power to the clock when I left the room, and when I came in the room, it would turn on the clock. So then that way I wouldn't burn out the bulbs. And but the problem was with that is it had a backlit light, and whenever I'd turn the power on to that, it would turn it to the to a really ugly purple. And so with the help of Ray, I made a little Arduino Nano that would trigger the color button on the clock every time the power was turned on. So then it would turn it to my preferred color. I also made my first PC around that time. And I also started working on I entered into my first 6-can competition. And I retrofitted the Cracker Jack robot this time as the 6-can robot. I used, well, how I ended up using this robot wasn't how I initially intended to use it. Around this time, I went on a month-long vacation with my family, and I thought that when I got back, I had at least a week to work on the robot, and I didn't realize until I finally got home and had good internet service that the competition was actually in 2 days. So I spent the next 2 days working as hard as I could, staying up at night to get it to work, but I had to give up on I was going to use the JVoy camera as the primary camera, and I had to give up on that idea since I knew there's no way I'd get that ready in 2 days. So I bought this new Pixie 2 cam that had come out recently. I think this was 2019. Yeah. And that worked really well at tracking the objects, much better than the old Pixie cam had. And so I added that on there, and I had it go grab a can with the Pixie 2 cam, and then it would turn until it saw the screen board on the side. And then I'll start the video now to show you. Then it would use these two front ultrasonic sensors to level up to make itself perpendicular with the wall and approach it. And then it would turn left once it had gotten close and use two ultrasonic sensors on the right side to follow the wall to this wall, and then it would repeat the process by getting close, turning, and using the two right ultrasonic sensors to go into the goal. And then I had a switch on top that would bump into the post and drop the can and repeat. Unfortunately, I wasn't able to get it to go through the goal, although I didn't realize at the time, due to the lack of sleep and jet lag, that this wasn't even the real competition. This was just a practice competition. I think others had told me that at the time, but it didn't register to me. So I had a whole month to work on this, fortunately, and I was able to get it ready for the real competition. And I changed some things up slightly that made it much faster and more reliable. I'll start it. I had it go grab the can, same as the previous one, and then it would turn and make itself perpendicular to the wall, same as the other one. But this time, instead of going all the way up to the wall, it was just going to go halfway to where it measured the distance of the goal was. And then it would turn and use the two right ultrasonic sensors to go through the goal. And I'm not sure why, but the robot was really slipping that day with the wheels. I never did that before, but for some reason that day it was. So I even had to add on that duct tape. But I was glad that day in particular that I was not using encoders to run it, because otherwise that would have definitely messed it up. And then there you can see the flag is about to hit the thing. So then it would turn and repeat. And I was like I said, I was very impressed with how the Pixie Cam did, because it was able to see all the cans. The only reason why it didn't see all the cans in this competition in particular was because I had it programmed so that it would slowly turn so that it could see so that the refresh rate would be able to tell the Arduino that there was a can. But then I wanted it to get to the can as quick as possible, so I had it take off towards the can. And as a result, it ended up turning too sharply for the distant cans, so that it would miss the can, and then it would just get stuck in this loop of continually turning and not being able to grab the can or see the can. But I'm changing that problem up now too, so that it's gonna, when it's further away, it will just more slowly approach the can, and then increase speed as it approaches. So then there you see it kind of took off and missed it. It still was able to catch this can for some reason, but there. But this is the last can it grabs.
And Jack, were you in high school at this point or college by then?
This was my senior year of high school.
Yeah.
Yeah. And I was able to get 4 cans in, which was able to get this robot 3rd place. There we go. And then here it will see the can, but it's going to turn too sharply and miss it. So after that, after the successive, thank you. So then I decided, since the Pixie Cam worked so well on that project, I added it on to the CoolBot to see how it would work with that. And I was very glad to see how well it did with the varied shadows. For instance, I think it just rained this day, and it did just fine with the mud and the puddles and everything. And I tested it out later on when it was sunny out, and did great with the shadow changes and everything. So I finally settled on the Pixie 2 Cam as my preferred sensor, and started adding on the finishing touches. I added on the cooler, and then I added on the money box, and I made a different bumper. The previous bumper I had wasn't very good, but this one worked very well. And the ultrasonic sensor and the stop button. And I cleaned up all the electronics. The pins kept popping out of the Arduino, so I added on this shield that was a little pricey, but it was very, very worth the money, since I just screwed in the pins then, and they did not pop out at all after that. And I added it onto wood board, so then that way any scratches that were on the paint wouldn't short anything. And I zip tied down all the loose wires and screwed down all the loose electronics. And here's a diagram of the electronics. So I had it all powered by a 12-volt battery, and that would connect to this power switch, which would then provide the positive power to the 5-volt voltage regulator that would provide power to through a diode to the Arduino, and this other 5-volt voltage regulator, which would provide a separate power to the servo. And then also the battery then provide direct power to the motor. I had 2 switches for the left and right bumper, or 2 sets of switches, I should say, for the left and right bumper. I had for each side of the bumper 2 switches on both the top and bottom, so just for extra accuracy to make sure that it detected any time that it was lightly bumped. And I had it set up then that way so that it would, if the loop was disconnected, then it would know that something had bumped into it, but when the loop was closed, then it would know that it was not triggered and that everything was okay. And that was the same for both the left and right bumper. But for the stop switch, to conserve power, I decided to have it where If the switch was closed, then it would trigger it that the stop button had been pressed. For the motor, I had a diode to short out any back voltage that the motor provided, and a MOSFET for the motor control unit. I was maybe considering planning on swapping that out, but I kind of like the simplicity and reliability of just using the MOSFET, so I stuck with that. And I also had the ultrasonic sensor, and I also had an encoder and a Pixie Cam, like I said, on there, but I couldn't add that into the diagram. The encoder was added onto one of these pins. Can't remember which one. And the Pixie Cam was connected to the ICSP port. Here's a slide showing the program itself. I'd start out with the initialization and setup. Then it would go to the void loop, where it would first only run through this sensor test section, which would make sure that all the sensors were working and everything was okay, before it would finally start on the real part of the program, which would be the sensor check and response, and the steering control and the speed control. The sensor test section would first check to make sure that the sensor test was not completed, and then it would check to make sure that the right bumper was not pressed. If it was not pressed, then it would wait for me to press the right bumper. And then I also used this section to make sure that the servo was operating properly. So I'd have it change the angle each time, and then that way I also knew that each step had been properly completed. And I'd then check the left bumper to see if the left bumper had not been pressed, and if the left bumper had not been pressed, then then it would wait until I pressed it. And it would do the same for the stop button. And then for the ultrasonic sensor, it would first make sure that nothing was in front of it. And if something was in front of it, then it would continue. And I'd wave my hand in front of it to give it that reading. And then after that, it would not run that section ever again, and it would begin the rest of the program. So this is the sensor check and response part. So I'd first make sure that the sensor test had been completed, and then it would check the stop button. If the stop button had not been pressed, then it would check the left and right bumpers. And then if the left and right bumpers had not been pressed, then it would check the power variable. And the power variable was just a variable that I had to set the power of the motor. And I just wanted to make sure that the power was above or at 0, so that it wasn't a negative number. And then I'd check the stuck variable that I had to make sure that it was not stuck. And then I'd turn the motors on and set the speed to power. Then I'd check the ultrasonic sensor variable, and if anything was in its way, then I'd shut the motors off and wait for 100 milliseconds. I had it only wait for 100 milliseconds since it got a lot of false readings, but I didn't want to have it, so I tried this out before where I was going to have it where if it got a reading, then it would count up, and then if it reached a certain number, then it would say that something was in its way. But I didn't like that idea because like sometimes someone would step in front of it, and I didn't want it to wait for a really long time before shutting off the motors. I wanted it to stop immediately. And so by having such a short one, it was able to ignore any false reading, but also be able to quickly react to whatever information it was getting. Then I'd check the left and right bumper. If they had been pressed, then it would shut off the motors and wait for 7 seconds. And then I'd check the stop button. And I had two purposes for the stop button. One was to stop it so that you could grab a drink. But also, if it was stuck, I used the stop button to let it know that it was okay to continue. So after I moved it out of its stuck position, I'd push the stop button and it would continue. So that's why it would then check to see if the stop button was pressed, it would check to see if it was stuck. If it was not stuck, then it would shut the motor off and wait for 30 seconds so you could grab your drink before continuing. And if it was stuck, then it would remove the stuck variable and set it to 0, and then it would wait for a second before continuing. Then so I didn't have the ultrasonic sensor reading every loop, since when I did do that, it took up a lot of time and made the refresh rate very bad, and I didn't need it to be checking it every loop. So I'd only have it check every 20 loops to make sure, and then I'd set the ultrasonic variable to that ultrasonic distance. And that seemed to be an optimal amount of time to be running it. Then I'd move on to the steering control part, which would check the Pixie Cam, and I'd check the width of the sidewalk block. And if the sidewalk block was large, then I knew that I was away from the curb, since it was reading the color of the sidewalk. And if it was short, then it would know that it was near the edge of the sidewalk, and it would steer away from that. And I'd set the angle then to a map of that sidewalk block. I think I had the angle set so that it wouldn't oversteer, but just to be on the safe side, I had this little if statement to check and make sure that it was definitely not oversteering and ruining that servo. Then I'd do the speed control part, where I'd have this new speed variable, which would check the number of ticks that the encoder had just read, and the old speed variable, which was set to the new speed variable after everything had been calculated. And then I had the speed variable, which was the which I'd subtract the old number of ticks, or subtract the new number of ticks by the old number of ticks to figure out the speed of the robot. I had the and then after that I'd judge the difference of the speed, and based on if it was a large amount of difference, I'd increase it by a lot or decrease it by a lot. If it was a short amount of distance, then I'd decrease it by a little bit or increase it by a little bit. And that was very necessary, since sometimes if it was going up a hill, it wasn't very good to have it increase by a lot, since I needed it to be continually increasing its speed as it was going up the hill. Otherwise, it would end up rolling backwards. And but if it was going down a hill, but if it was going down the hill, sometimes it would take off, and I'd need it to be decreasing its speed by a lot. So I'd have to decrease it by a lot. So by having it vary how much it increased and decreased it, that helped it be able to solve both of those problems. I also had then the stuck variable, which so after, if the speed was low enough, then it would increase the stuck variable to a certain level. I didn't want to have it immediately declare as stuck, since many times it would just get stuck in like a little crack for just a second, but it would be able to get out of it pretty quickly. So I'd have it count up until 50, and if it reached 50, then it officially said that it was stuck and shut off the motors. So that was it for the program. Here's a video of it going up the steepest hill that I had in my neighborhood. I don't have the video of it going down, but that it did well with that as well. I had 6 cans of soda in here and some coins added in for little extra weight. The video doesn't show it too well, but this was a very steep hill, so I was very glad that I was able to handle this hill without any problems. And so I think he briefly stopped for that kid. I can't remember. The video doesn't show that too well. So the rubber stuff here simulated grass for it, but it worked just as well in real grass too. I think I had to have it on the grass side anyway when it was going down. Also, this was a very muddy path, so I was glad to see that he handled all of that all right. There were a lot of posts on this area too, and that would occasionally mess up the sensors. I think it should start triggering the ultrasonic sensor now. but he did all right with just briefly pausing for that. Like there. So then I tested out the ultrasonic sensors by standing in its way so that it could stop. And then I continued and I pushed the stop button so that I could grab my drink. And that was it for the hill test. Then I tested it out going down a slightly smaller hill on its way back. And with this one, I wanted to see partly how it would do with stopping as it was coming down a hill. And since I didn't actually have a braking mechanism for this robot, so it was just using the friction of the bearing to stop, but it did a pretty good job with stopping. It did coast for a little while, which I was glad then that I didn't have it shut the steering off when the motor was shut off. So that way, when it was coasting, it was still able to steer. So after that, I added on some, I cleaned everything up. I repainted a lot of the old scratched parts, and I added on the final paint job for the title, and I also added on, I accidentally dropped the robot out of the golf cart when I was driving it somewhere, and that ended up cracking this money box. So I added on these little pieces to help hide that, but that ended up being a nice decorative piece. So there you can kind of see, it looked pretty similar to my original sketch that I had when it was all said and done. So I was glad to see that, just without the flag, of course. And then after that, I was ready for the big final test where I was going to have it drive as far as it could until it just ran out of sidewalk. So it ran for about a mile in this test. I'll start the video. And I made it into a time lapse since this did go pretty much all day. And there were 3 scenarios that I'd have to actually pick it up and help it out with. And the one scenario was large potholes and cracks, where it would basically take up most of the wheel. So I didn't feel like that was a very fair challenge anyway, since the golf course, as far as I'm aware, didn't have any cracks that were nearly that big. And the other thing that I'd have to help it out with was crossing the street. But I also didn't feel like that was a fair challenge, since the golf course that I was going to run it at also didn't have any streets that it would have had to cross. And also, this day that I was testing it out on, there were the lawn was being mowed next to the sidewalk. So there were a lot of grass clippings that were all on the sidewalk, and the robot kept thinking that it was running into the grass then. But aside from that, it did it all completely on its own. And as you'll see, I'm going to go sit away from it for a little while, and it's going to run completely on its own. Also, I was glad to see that it went through that puddle. That was a big puddle, and it did all right with that. And this was a very hot day too. It was, I think it was like 90 degrees out, but I was glad to see how well the cooler kept everything cool with the ice and everything. I had it fully loaded with sodas and ice, and when it was all done, the soda was still ice cold, and the ice had just barely melted. I think it ran into a giant pothole there, so I did have to go help it out with that.
how did you detect stuck?
Oh, so if the encoders detected that it wasn't moving, then I'd count for a certain amount of time, and then it would say that it was stuck, and shut off the motors. So there you see a lot of the grass was mixing it up. And
Were you using like the color detection in the Pixie Cam or
yes,
area?
yeah. Yeah, I
Or-
tried the new line following feature that the Pixie 2 Cam had, but it didn't work too well. Also, it started getting very sunny at this part of the day. I was glad to see that the change in sunlight didn't affect it.
And you weren't tempted to stop it and grab a drink on the way out?
I was. I finally did when it was finished. And I enjoyed that drink. Yeah, I kept thinking it's almost done. Just wait, and then you can drink it.
Hey, Jack, how did it handle T intersections?
It didn't. That was one of the scenarios where I'd have to pick it up and help it across. But like I said, the golf course that I was initially planning on using it at didn't have any T intersections that it would have interfered with. I was, if I were going to add any more to it, I would also add on GPS specifically for that. But I don't know. I might change it up later on. But so that was it for the big test. After that, I officially said that the robot was done, and I've started. Oh, sorry.
Very cool.
Oh, thank you. Thank
Nicely
you.
done, Jack, on that.
Thank you.
Jack, if I could just make a comment,
Yes.
as I watched you go through this process, you have solved a whole lot of the very fundamental robotics problems. You have a leaky integrator there with your stuck algorithm and controlling the speed by reading encoders. I mean, a whole lot of the very fundamental problems you have solved quite elegantly. So, bravo.
Oh, thank you. Definitely couldn't have done it without your guys' help on a lot of those. So after that, I've implemented a lot of the lessons that I've learned from that robot on some of my other robots. I've changed the Crackerjack robot up a little bit. I've added on this LiDAR sensor, and I've added on this Husky lens, which instead of the Pixie 2 Cam, which I'm leaving for now with the cooler robot. And I've also made the flags that can raise and lower so that it doesn't interfere with the LiDAR sensor. And here's a video of it running. So the LiDAR sensor detects the angle to the wall and also the distance, and then the Husky lens just goes and grabs the can. I also changed up the grippers so that my other grippers would accidentally shove the can underneath the robot and get it stuck. So this way, this new gripper keeps it solidly upright. I probably could have used the LiDAR sensor to detect when it goes through the goal, but the flag raising and lowering is much more fun, even if it does cause the problem that you'll end up seeing in this video. So here you'll see it wasn't very securely put on there, so the flag ends up falling off. But I've since delayed working on this since since COVID we haven't had the 6-can competition, but I am planning on starting up the project again once we plan on having that competition. But during that time, I've also started working on this. I've really realized since college the necessity of coffee. So I'm now making a robot to make mochas for me. And I'm going to have it, it's going to grab a cup, then it's going to fill it up with the mocha syrup or sugar or whatever else I want in there. Then it's going to mix it in a mixer section that I now have, but isn't in this video. And then it's going to fill it up with coffee. I still haven't bought the coffee machine. I'm waiting on that till it's almost completely finished. And then it's going to stick a cap on it. And a lot of the features, I've got the hardware all set up for it. I just haven't written the program yet to fully integrate it all together yet. But hopefully, maybe within a couple months, I can show that to you guys on one of these Tuesday meetings. But I'll show you the video of it grabbing the cup. I bought a new 3D printer recently, and I used a lot of the parts from my old 3D printer in this robot. So for instance, the part that raises and lowers the gripper was the bed raiser of my old 3D printer. So grabs the. I've got a solenoid dropping the cup. I previously was going to have it to where it was going to just pull down the cup, and it was going to have like a little springy thing attached on it, but that was just too unreliable. So the solenoid valve has been very reliable, and it goes on for a long time, but it eventually empties the entire stack. But I've learned a lot of lessons from the cooler robot that I'm incorporating into this coffee robot. One of which is how much easier it is if you clean up all the electronics at the beginning. So I've saved a lot of Arduinos this time by making sure that all the proper electronics are in place to protect it. Yeah, I'd probably still be trying to figure out what's wrong with my Arduino, but fortunately there hasn't been anything wrong with my Arduino yet. I haven't shorted any of them. And then also, the lesson of just keeping everything simple has been a big thing that I've been incorporating into this robot as well, since now it's able to, I'm able to keep it pretty cheap, and it's also very reliable too as a result. So the main reason why why the cooler robot so far has been my favorite robot is that I was able to really follow the KISS method of keeping everything simple. And for instance, I was able to keep much of the mechanical parts pretty simple, and I was able to keep the electronics very simple. I was even able to keep the program very simple. And as a result, it was very reliable in following the path. It was also pretty cheap. Like I said, it wasn't my initial goal, but I think I ended up spending a couple $100s on it by the time it was done. And also, it wasn't my original 3-month goal, but I was able to get it done within 3 years, which I don't think is too bad for getting a project fully completed. And it was still able to complete a pretty complex task, even though it was that simple. So, yeah, I think that's about it for the presentation. I appreciate all of your time, and I also appreciate the club's advice and encouragement that you all have given me with my projects. If anyone has any questions, I'd be glad to answer them.
Excellent.
Yeah.
Thank you.
Very interested.
Thank you.
So Jack, I mean, for 3 years, it's like it wasn't exactly scratch, but you were starting from pretty close to scratch, I think, from 3 years, right? I mean, there's a lot of lessons.
Yeah.
Engineering training to start off with, but you're coming at it cold, so.
Oh, thank you.
Jack, I had a professor that told me that you don't have to work to make things complicated. Things get complicated by themselves. You have to work to make them simple. So, I mean, that's a life lesson, you know.
Mhm.
That is true. Yeah, and yeah, I know you guys are always talking about the KISS method, so that has definitely sunk in for me in terms of how I should be designing these.
Jack, what happens if CoolRobot, what happens if something touches the bumper?
So it will pause for 7 seconds, and then we'll continue on. I had it recognize the difference between the right and left bumper, because I was planning on changing out the motor control unit, maybe, but in which case I was going to have it kind of back up and kind of bump around whatever was in its way, like a Roomba would. But I ended up deciding on not doing that, since I thought there could be a chance that it would accidentally run itself off the course if it was trying to do that. And so I thought for safety reasons, it would probably just be best if I had it just wait at the object that it was at until I could assist it.
I have to say that I've always envisioned in robot building that I'd take a robot out and turn it loose, and it would just go away out of sight. But in practice, I don't want to do that. I want to see what it's doing.
Yes.
You know?
Yeah.
So basically, what I end up doing is sort of what you showed, which is taking my robot for a walk.
Yes.
And if you're along with it, you can solve some of those problems, like if it was a dog or a child. For example, the J-Bot, I take on a walk to a GPS waypoint down in the park. And when we come to the intersections, if there's a car, I just chase it back up into the yard. And, you know, when the car's gone, then I get out of the way and it'll cross the street. So I can do that part, the danger, just like you would, as I say, with a child or a pet.
Right.
So taking a robot for a walk is a high honor.
Yes, it is a lot of fun. It is a lot like a pet in that way. Mm-hmm.
What type of comments do you get, Jack, when people see it?
None, actually. I was kind of surprised by that. They don't even look at it. They just walk right by. Yeah.
Is it just another kid and his robot out for a walk? Is that the deal?
I guess. I think I did get like 2, actually. But yeah, I felt bad. One day it was hot out and I was working on it and I wasn't up for really talking to the person. And it wasn't going well either. But yeah.
I've seen that same thing. I actually took J-Bot out and ran it around the engineering campus at North Texas. So a bunch of engineers, wouldn't they be interested? Nobody said a word.
That's weird.
Walked ahead.
That's weird. You know, we've got these Starship robots at my new college, and they're running around all over the place delivering food and drinks, and nobody looks at them. I'm the only one that's like watching it the whole time, and everyone else is just walking by.
I've had the same experience where I've taken my robot out and I'm having it drive around, and everyone's just ignoring me.
Yeah.
Maybe they just think it's routine. I will say, you know, the kids are pretty fascinated when they find out they can interact with it. You know,
sure.
If they're just watching it, and I'll say, go around, stand in front of it. So they go stand in front of it, and it goes around them, and they're hooked. But this was some years ago. I was headed down to the park, and this young girl stopped, and she said, "What is that?" And I told her, and she said, "Where's it going?" And I said, "Well, there's a GPS waypoint up in the park. Do you know what GPS is?" And she's like, 8 years old, and she nods, yes. I said, "Whoa, you know what GPS?" And she said, it's like geocaching. Remember geocaching?
Oh yeah. Yeah.
So we get down to the park, and she's following along, and she runs over to her friends, and she says, "Look, this guy has a geocaching robot." And they all came and sort of chased it around for a little bit. And I said, "Well, let's let it go and let it get to where it's going." And so they stood back, and it got over where a basketball game. I was actually shooting for the middle of the basketball court, but there were a bunch of kids there playing basketball. And they saw it, they all stopped, and they just kind of watched it. And then they went back to playing their game when it left. They didn't comment or anything.
Huh.
It disappeared off into the ditch.
Yeah. I do wonder if they maybe thought that my robot in particular is maybe remote controlled, because I am standing right behind it, walking with a phone. So
I think a lot
like
of
that.
Yeah.
Yeah.
Well, that could be true.
Shy or interfere or whatever. Think about how many things you see and you feel it might be rude to go up to the person, even though in later days I think I'm more interactive with people on random things. But
Ruder.
Pardon?
You've gotten ruder?
Yeah. Hey, but the Sam's had a floor cleaning robot, and boy, so I went over there and messed with that thing. I wanted to see what it would do, anyway.
Yeah. Or could it be that we're just so desensitized now with all the TV shows and movies? I mean, of course the robot can drive around. What robot couldn't? I mean,
I think that's a big part of it. I think
the
all of the multitude of underlying problems that have to be solved to get that to work, it just seems like, well, of course, yeah. What else would it do?
I mean, it'd be a bad robot if it couldn't drive itself around. I mean,
maybe if it was trying to kill you, it'd be a bit more interesting.
Well, I've seen along those same lines, people would come up. I used to take one of my robots to the parties that we had here in the geology department, let it run around. And people would say, how is it navigating? Does it have a camera? And the implicit in that question is, if I were to say yes, then they would go, oh, it can see. I can see, it can see. Problem solved, Little
do they know.
Well, Jack, that was excellent.
Oh, thank
Excellent
you.
presentation.
Thank you.
Bravo.
Yeah.
Yes, thank you all for attending. That was very nice to have this opportunity.
Of course, this means the next competition, there's going to be a lot of us that are thirsty. So,
Yes. Well, if there's a sidewalk there.
When you first described what you were going to try to do, I just thought, well, that's just brilliant because it's a constrained space, which is always a problem. And you have a how can I say it, probably trustworthy audience that you're trying to sell to. And they'll be fascinated by it. And then after a while, they'll just look around and say, well, where is it? I'm thirsty. Doggone it.
Yeah. I still do like the idea as a business idea, but.
Yeah, Jack, have you thought about looking at having an app or whatever on a phone or using some of the pay apps, that sort of thing? Or even your own app would be sort of interesting because then a lot of the interaction, would be taken care of by your app. And I guess you could have, would totally eliminate almost the need for a user interface on your robot, I guess.
Yeah,
Right.
but it'd still need to have cellular.
Right.
Yeah. Okay. Or some Wi-Fi connection, that sort of thing. Okay.
Mm-hmm. I was just thinking with the RTK GPS, can you communicate through the base to your robot through that system? Like, can it share more information than just location, or can't remember what the RTK beacon does. Is it just sending out a pulse, or is it also receiving information?
Yeah, it's just, I think for RTK, the base sends correction information to the rover.
Okay, so it doesn't. So the rover doesn't communicate to the base either. Oh, okay.
No, not as far as I know.
All right.
But yeah.
Mm-hmm.
Remote links are always a place where failures can happen. I just think that the smarter you have on board, the better off.
That is true. Yeah.
Yes, Carl can and I can attest to that.
Trying to put a radio link in the loop. It's almost as bad as putting a person in the loop. So,
but the original arm that you showed, that you were concerned that didn't have limit senses and so forth. But basically, the way it's designed is for a human to do that, right?
Right. Yes.
You're pushing buttons and watching the arm until it gets in the right place. So there's this complex 3D feedback with object recognition and all that, but it's not on the robot.
Yes.
Yeah.
Yeah.
When you put a human in the loop, all that stuff becomes trivial, and I lose interest.
Yes. That was one of the big things starting out with robotics that I didn't realize, because I always thought, oh, if you've got something you want to do, just put a camera on it, right? When first starting out anyway, and then you quickly realize no. Also, I didn't realize, I was going to initially have it point at I was going to point out an object with a laser and I was going to go grab it. I hadn't thought through until later that even when it does approach that object, you've still got to determine the size, how to grab it, and all that. Yeah, it's part of the reason why I still haven't gone back to that project yet.
Those are things that we humans find so trivial to do ourselves that the assumption is that it would be trivial for a robot to do. But Rodney Brooks' example about reaching into your pocket and you've got a bunch of things about the same size and shape, and you just with a couple of finger touches, you identify the right object, rotate it into position to be grabbed, and pull it out of your pocket. And how that's basically with current robotics, that's an unachievable thing. We can fly an airliner from New York to LA and land it autonomously, but we can't fish the thumb drive out of your pocket.
Mm-hmm. Yeah. Even the airliner thing, we can't do it reliably enough to where we can actually take people out of the equation.
I wouldn't get on one.
Well, I think the point here is that with computers and robotics, if it's easy for a human to do, it's really hard for a robot or a computer to do, and vice versa. If it's hard for a human to do, it's usually very easy for a computer or a robot.
I can't tell you how glad I am to hear that you guys don't want to get on airplanes without pilots, especially great guys like yourself. Keeps me employed. Thank you.
So saith the pilot. We appreciate that. No.
Yeah, can you imagine a Boston Dynamics Atlas, walking up in a captain's hat? It's like, no.
I will say that just as a parenthetical aside, that when Willow Garage closed down a few years ago, it was 10 years ago, I read an interview with the CEO. I can't remember his name. And he was, these are venture capitalists and business type guys that put all the money into this because they, like we were just suggesting, they thought, well, how hard can it be? And the most basic problem, anyway, one of the things he said was having a robot roll up to a table and identify an object and pick up that object, it turned out to be such a hard problem that they really couldn't solve it. And basically what they did, if you remember, was they switched over to try to do telerobotics. And that was how they were going to try to make their living, but basically abandoned the idea of the robot being intelligent enough to do anything on its own. And I think that was a real, for me, a real seminal event. And these are a bunch of smart guys from Stanford and had a lot of money, and they couldn't do it.
The one that I like is, they have the robot go over to a refrigerator to open the door and grab something out of the fridge, and its hand gets caught in there, and it's like wrestling with the refrigerator, and it's got the refrigerator almost on its side, crunched up the handle and the metal around the front of it, got all tangled up in it. So.
Well, I've said this before. It's one of the wonders of where we are right now. We're kind of like where the Wright brothers were. And that is, the great big government laboratories don't really have an advantage over a couple of guys at bicycle makers in their garage, and really fundamental contributions can be made. Nobody knows where we're going,
Yeah, and there is, some evidence of progress with robotics, because if you look at like auto manufacturers, they have robots welding together cars all day, doing everything perfectly, painting the car, everything.
Yeah, I actually got a scholarship from General Motors. They had spent 2 summers at the assembly division at Willow Run, and the body shop was a place that you did not want to be. There were all these, robots doing spot welds, and hundreds of spot welds in a minute. along the edges of door frames and, you know, rocker panels and that kind of stuff. So you had all these sparks shooting off all over the place, and the metal was coated with, you know, things that would prevent rust, and that would burn as you spot weld, and there wasn't very good air circulation in the place, so it's this, you know, and the smoke would irritate the heck out of your eyes, so, you know, your sparks are flying all over the place, it's smoky, you know, and it's not the place that you want to be. So, but yeah, but you know, with positioning, they could put spot welds pretty repeatably along seams or pieces that they wanted, you know, welded together. So, been doing it for a long time. The other one was paint. They would actually mimic what a painter did to get the right angle of the paint gun to whatever piece of sheet metal was being painted, and, you know, with the right amount of overlap. And on that line there were just 3 different cars being made, so they could, you know, they knew which car was coming up next, and, you know, if they had to make changes, they even had an arm to open the door on the body to paint the inside of the door. So but that's another place that you didn't want to be. There are all kinds of, you know, VOCs floating around in the air, and again, poor ventilation, and, you know,
I wonder now if the painting, if certainly the software is improved, I wonder if they just work directly from the solid model that was used to make the door panel, and they might have the ability to just not even have to train the robot per se. I mean, that would be an interesting thing to look at.
Yeah, that was, let's see, when was that? 1981 and 82. So yeah, it's probably changed a lot since then, but yeah. So
one of the stories I remember hearing was where some people were going to visit one of these automated plants, and they turned on the lights so the people could see what was going on.
Yeah, you don't necessarily need lights.
Lights when the robots are doing it.
Yep.
My wife works in radiation oncology. She's a medical physicist, and they have this, they call it a cyber knife, but it's basically a table you put the patient on, and then the thing that has the linear accelerator that provides the radiation treatment in a beam, it's on the end of a Detroit style automotive assembly robot. So it can basically, the idea with these cancer treatments is that you concentrate the radiation in a particular volume where the cancer tumor is, and then you minimize the radiation in the other parts of the surrounding tissue. Yeah. So what they do is that, you know, you get a person on a table, well, people breathe, right? Their chests go up and down. And a lot of times the tumors are there in the chest. So what they'll do is they'll use CAT scans and whatnot to locate where the tumor is within the chest cavity, I guess. And then they'll put a sensor on the person's chest so that as the person breathes during treatment, this machine is trying to like shoot the beam at all kinds of different angles to concentrate the radiation. But as the person breathes, it kind of adjusts where it's angling the beam to compensate for the elevation of the chest real time. It's the craziest thing. She showed me without the radiation in play, but it's pretty neat to watch.
Sure, hon. Just lay down here. I'll give you a demonstration.
Well, that kind of goes back to what Ted was saying about things that computers and machinery can do well that humans can't, and vice versa. What Ray was describing about the painting robots trying to mimic what the human would do, you know, it's kind of the opposite, right? It's the more optimal is the way the human would do it, not the way the robot would do it. I know we were talking one time, I've got this reciprocating saw, it's a pipe cutter. You know, farmers use them to cut pipes all the time. And it's a pretty complicated thing, you know, it cuts on the downstroke and then it has to lift up in the air to drop all the chips out and so forth. And those were basically the first bandsaws that were invented. That's how, you know, they were in old mills and that's how they were driven because it made sense. In other words, what they were doing was modeling what a human would do with your arm. So you turn this rotating movement into a back and forth movement, And as I say, you got to lift the blade on the way back so the chips don't bog up, and it's complicated. So evidently, it was like in the 1700s or 1800s, some woman inventor in England invented the bandsaw. And this idea that you always go in the same direction, you don't have to lift the work, you don't have to get rid of the chips, and it's just a whole lot. But it's not the way a human would do it. You know, just like airplanes don't fly like birds fly. You know, the machines do them differently, and that seems like there's some. At least for me, there's always an urge for me to think, well, how would I do it? You know, that must be the optimal way. And with computers and robots, it's probably almost always not. And that's all I have to say about that.
That's it. All right.
Hey,
Well,
so
guys,
does
I guess.
anybody have any show and tell? How's that?
Say what?
Oh, I was just wondering if anybody had any show and tell.
Do you have any show and tell, Ron?
Yeah, a little bit, not much.
Okay, hey.
But I'll show it, I guess. Is this a good time?
Jump right in.
Sure. Okay. I kind of some years ago I played with Unity for a little while. It's a huge monster beast, but it's very powerful. It's the game engine that's freely available, I guess, if your revenue is under 100 grand, and I don't know if that means just for Unity itself or total, but in both categories I'm under that right now, so that's not a problem. But anyway, pretty neat game engine, and I haven't done that much with it, but I had pursued integrating a physics engine into processing, which I was using. David Anderson's friend Russ Smith wrote a really cool dynamics engine library, I don't know, about 20 years ago. And anyway, so I had spent a fair amount of time integrating that. But what I really liked about Unity was the graphics capabilities. There's just many more people that have invested effort into creating all sorts of, graphics effects, being able to efficiently render things like trees and grass and stuff like that, and different lighting conditions. So anyway, so I decided really I would abandon my efforts in processing and switch over to Unity. So right now I'm just barely crawling. But the nice thing is with tutorials, any given subject, there's really good experts that will lead you through, and you can get up to speed. And so I've started to pick on a number of different topics. And my goal is to create a three-dimensional robot simulator. And I know there's other packages out there. I know Ross is big into that. But I figured with Unity, I'd have kind of an edge in doing photorealistic and some different fun things, along with reasonable physics. And I'm not after total realism, but anyway, I can give you just a quick, I'll grab the screen and I'll just show you, and I won't go on about this, but my goal is within the coming months, maybe even 3 or 4 months, I might have at least a presentation or a more advanced type thing, but I'll show you what I'm doing anyway.
Jack says that means 3 or 4 years.
Oh yeah. Well, the thing is, I've got a lot of 3 or 4 years, but I've got to say that it's interesting that even though I'm familiar with a lot of concepts, and Unity uses C#, which looks almost like Java to me. I mean, there's just minor things in there, but it's slow going for the old geezer Ron. But I'll get there, I'm sure. But let's see if I can present, and we'll see what screen shows up. Wait a minute. I'll select the window or screen. I'm going to guess. Let's see. Now that's not right. Oh, well, that'll be good. I'll drag things around. Okay, so let me. Okay, is that showing up?
Yep.
Hang on.
Yes.
Okay, so you can see the little box robot there.
Yep.
And the cone. Okay, great. Okay, this is the Unity editor here. And for those who haven't played with Unity, it presents like a hierarchical organization. Well, it's really good at organizing things, put it that way. Like projects, you have all everything from materials to scripts, and you can, you have a file structure that you can define, and it makes it really convenient to organize things, and also to have the ability to see things visually. For example, I'm not very good modeler. So, okay, I modeled a traffic cone in Blender and then brought it into Unity. But Unity supports a lot of primitives, simple primitives. You don't have to really get into that much modeling. And what I did is I found their internal simulator for a wheeled vehicle seemed to have some shortcomings. And actually, I found somebody who published a wheeled vehicle simulator to GitHub that's part of, I guess, the Kerbal Space Program simulator. So I've just started playing with their simulator. Let me see if I can bring up a runtime screen. Here we go. Let's see. And let's see. Here we go.
Ron, did you mean to stop presenting?
Oh, whoops. Did I stop presenting? Oops, hang on. You were sharing your entire screen. Oh, hang on. Maybe it's not going to work. Wait a minute.
We can pin it if need be, but I think you were presenting and then you stopped.
Okay, hang on. You're sharing your time. Okay, wait a minute. Okay, hang on one sec. Oh, let me find 1 second.
At least I think so. Is
and maybe it froze up. Interesting. Maybe it won't display. Let's see. Well, wait a minute. So you're not seeing anything. Let's see. If I stop, is it?
Well, if
oh yeah, no, you're no longer presenting. Wait a minute. Okay, hang on.
There we go.
Okay, let's see if it'll tolerate it.
Yep.
Okay, so there it is. Okay, now let me see if I can bring a runtime. Let's see if I can execute the program. Okay, are you seeing it still?
Yep.
Okay, great. Let me, hang on, let me
Is that snow?
Yeah, that's snow. That's what I love about Unity. You want snow? You got snow. You just look at a tutorial, there's a particle generator, and so that's kind of what's motivating me along here. Now let's see if I drag this over. Now, are you still seeing it?
Yes.
Okay, great. Okay, so here's my little cone from Blender, and they don't support a lot of different colliders, like simple colliders. They have, by collider, it defines the physical extents of your object. Now let's see if we can get this robot rolling. Okay, is it rolling there?
Yep.
Yeah.
Okay, great. So I just wanted to show you that realistically, I can bash into a cone and it looks pretty believable. But so that's pretty much it. I mean, this simple environment, someone else created these objects, but this is not difficult to create in Unity. So let's see if I can run over something here that's a little more. Hang on. Sorry. I'm using a keyboard to control this, which is pretty lousy. Whoops, we're slipping. Hang on. I'm not a gamer, so WASD doesn't mean much to me.
And it's got first-person view, this robot does.
Oh, yes. Oh, that's the other thing. There you go. So this is I'm working toward having the ability, and the robot can get airborne over some of these hills, is the purpose of the first-person view is it's a camera on the robot, and what I'm working on now is integrating the Opencv library, which they have. Someone has done that, but there's some difficulty there in just my understanding of how to export textures from the GPU, which this image right here is a GPU-based image, and it's very efficient. It's taking and rendering it to this little window, but now the next phase is to pass that over to Opencv, where you can use things you're familiar with. I'm just assuming people have played with Opencv, so I'll do blob detection and that sort of thing using Opencv. And I think it will be a fairly useful simulation. Already it gives me the feel of a lot of the things with a real robot, running into obstacles and things like that. So I'll get out of the presentation mode. Oh, and let's see. Oh, and what motivated this? Let's see, 1 sec. If if I've blown it away, wait a minute. You have a blank screen probably. I'll quit presenting. Well, I'll go in, I'll stop this presentation there. Anyway, kind of what motivated this is I noticed that someone had done or created an interface between the robot arm I have, the Universal Robots UR3. It's a thing I think I might have shown it a few weeks ago, wherever it is, somewhere in the corner there. Anyway, it's a nice robot arm, but somebody had created an interface between that robot and Unity, and that's cool. And so far, I've managed to import. Let's see if I've got a picture of that. Here we go. I'll just show you still. Oh, anyway, I'll have to go back to presentation one sec. But what motivated me to kind of really get into this, let's try this. So someone had created a model of this universal robot arm. Can you see that right there? Uh-oh.
Yep.
Hello? Okay,
Yep.
good. That's that. Okay, end of that presentation. Anyway, someone had created a interface from Unity to that robot. And anyway, to this point right now, all I've done is import the model. But what really fascinated me is that then there was a nice, let me think, socket-based TCP/IP interface to the robot. And it made me think, hey, that's pretty cool. So Unity, I could use that to talk back and forth to a real robot and that sort of thing. So that made me think, okay, even more reasons to play with Unity. But anyway, I don't know if that makes sense, but that sort of got me thinking, okay, this will be powerful enough to do what I want to do, and I'll have a lot more capability than with processing. Although, albeit more complex, I still think that I could create a simulation that would be fairly easy then for someone to get into and write scripts to control a virtual robot. So anyway, that's blah, blah, blah. That's what I'm doing. Anyway, any questions or any comments?
Excellent, excellent, Ron. There was a guy in the Seattle Robotics Group a number of years ago who, as I remember correctly, he was integrating the physics of a game engine into controlling his robot. It was a four-leg walker, I think. But so basically the game engine did the physics for him, and then he could take the outputs of that and try to drive the robot and then read back what the robot actually did. I don't know whatever came of that project, but I was very intrigued by it because those game guys have already solved all that,
They do interesting things. And that, I think I was talking with Will about this. I'm kind of curious what is being done with originally legged things, humans and so forth, were done, I'll call it, I think the word is cinematically. They would either do motion capture or whatever, and just basically have humanoid, three-dimensional models animated through, whether it be somebody hand manipulating, a graphic that is, they add things like bones and, articulated things that are automatically, what do you call that? Trying to think of the word. Anyway, well, where you put bones in an object or into a being, and then you define, what their degrees of freedom are. Like your elbow would have a single degree, or your shoulder would be a ball joint, that sort of thing. But anyway, early graphic stuff, really the characters were pretty much just animated like cartoons. In other words, they would have a walk sequence or cycle, and some animator would sit down and move the bones of the graphic character, and they would record that sequence and then loop it. And then they might have several different sequences, and means of also interpolating between the poses. For example, a walk cycle might be blended into I don't know, a different cycle, a sitting down in the chair cycle, whatever. And they'd have about 100 of these different animations. And then the kind of the cool thing there, though, is the transition from one to the next using, often linear interpolation or different interpolation techniques. Okay, so that's cool. That's one thing. But then later, of course, physics came along. And so the first thing I think that they started playing with was you still might have a cinematic character, but then what they would do is, in the case of like a shooter game, somebody, you shoot the guy, he turns into a rag doll, which is now really controlled by physics. But the rag doll has all the structural elements, those bones and degrees of freedom. But then they start using forces and have the rag doll interact with other objects. So, you shoot the guy, he falls over, but he might fall over a box or whatever, and the physics would all be there, and the person would realistically fall over the box. But now something that I'm just because I'm like pretty ignorant about all this, but I did see something where now they're kind of using like active rag dolls, where they take the rag doll, but then they add in sort of the goals of, let's say, walking. But the interesting thing is that you have a goal of walking, or whatever it is, but you're limited by the physics, which fairly accurately models the real world. And it kind of brings up that question to me is, I'd like to know more about how that works. Because, if you have the thing, it's sort of like, what is Boston Dynamics doing? Are they doing that? Or is it something different? When they have Atlas walk, are they guided by a cinematic walk cycle, but yet governed by the physics that, in their case, if it's operating in the real world, then it's real world, or probably almost identically would be a good physics simulation running, on a computer, that sort of thing. So that's an interesting thing.
I can't remember which presentation it was, but I could swear it was one of the ones at DPRG, or it might have been one of the Seattle Robotics ones. But somebody has shown simulators where they have basically each robot is an agent, so it's an agent modeled simulator, and then the agent robots teach themselves via I think it's reinforcement learning. Goal-oriented reinforcement learning. So basically, somebody modeled up. I know it was the guy who did the presentation on the one four-legged robot, and he had showed how in universities they made the physical model with the right joints and structure of the legged robot, and gave it its parameters of what it could do, and then it set the goals of walking or something, and it showed how, with 1,000 of these agents, you just give it enough time and they would learn to walk in different, but they would all tend towards a similar gait but they were all just reinforcement learning, building their own neural nets for how to do it.
Ron, go ahead.
I was going to say there was also along Carl's, there was another one that we saw recently, and I think it's in the list, of a little race cars. And the guy creates like 1,000 race cars, and they all run. And then the one that gets the furthest, he becomes the mama of all the next 1,000. And within, I don't know, 4 or 5 times, he's going all the way around the course with obstacles and avoiding other robots. And I mean, it's a phenomenal thing. I also wanted to show you, I put something in the link, and let's see if I can. This uses this little training session. It's free, and it does use. I've actually worked through it, and it uses Unity. So let me see if I can figure out how to do the presentation. Okay, here we go. Let's see. Are you guys seeing this?
Yeah.
Okay. So in this, you use Opencv basically to create this guy on top of this video. And then he opens up Unity and then essentially transfers it over to this. So it might be something that you're interested in. It's free. It's fun. It was my introduction to Unity. That's the first thing I've ever done in Unity. So anything, kind of cool. Links in the chat.
Ron, I was going to say, I know no more than you do, but I have an opinion. For one, I posted recently, meaning within the last year, a link to these guys who had set up this simulation to learn to do hide and seek. Do you all remember that? You know, they took millions of runs, but it was incredible what they learned how to do. No, I was going to say, when I was working on the two-wheel balancing robot, I had it in my mind that first I would teach it how to balance. I would learn how to balance in place so it wouldn't fall over if it was shoved. And then after that, I would figure out how to make it move, how to drive it. But what I found out in practice was that once I got it to balance, so it could resist if you shoved it, then it already knew how to move. All you had to do was offset the center of gravity in software, and it would begin to fall in that direction, so it would drive in that direction to maintain its balance. So that's suggested to me, and as I say, I don't have any information, but I have an opinion, that all of these, as you say, the cinematic, which is kind of like old-fashioned rotoscoping, you know, motion capture, and even motion capture plus physics might not actually be necessary. If you could just teach your two-wheel or your two-legged robot to balance, to resist being shoved, then all you'd have to do is now lean it off center and it would walk on its own. You wouldn't have to come up with the gate. The gate would arise from its need to balance. That's my opinion, and I'm sticking with it.
Well, you know, I guess the question might be, though, a little help, have it take a step and balance. And
well, think about this problem. Put your enormous brain to work on this problem.
Do you lean forward or do you take the step first? Oh, go ahead.
Well, obviously, you can lean forward and you can still balance. You don't have to take a step. But when you lean far enough, when your center of gravity is way outside your base, you'll have to take a step. So teaching it to balance in place would include how to step forward and backwards.
Okay.
And then all you do is, as I say, if you lean with your center of gravity outside the base, the only way to stay balanced is to start moving. And with the balancing robot, as I said, it turned out to be trivial to make it travel.
Hey, Ron, you know, you were talking about movies and stuff. Well, my daughter's in that, and basically the flow is they have a modeler who creates the character. Then they have what they call a rigger, and the rigger puts in the skeleton, okay, or the joints that'll move, and then that goes to the animator.
Right.
So that's the kind of the three steps. There's also a concept guy in front of them, but so, you know, it does sound like, you know, once that guy does the animation of the film, you know, you see film all the time, you know, it looks pretty good. It would seem that they could learn an awful lot from that when they're doing their, you know, you could say you could rig something, make it do something. You should be able to capture the poses and incorporate it with something else. Now, I don't know if that would be flexible enough, but it would get you a big start. It would eliminate a lot of wrong things, I think.
Yeah, you just wonder, you know, how Boston Dynamics is choreographing their robots. Do you think they're using motion capture? Do you think they're?
No, I think they're rigging them. I think they're rigging them, and then they're having an animator go through all of those motions, and then somehow they're capturing those points and using them at least as the starting point for their dance.
Yeah, Maya is one of the programs that is.
So yeah, Maya's key
for animation, and it has all the rigging and what have you.
Yeah, Blender too. Whoops. What's people waving? Go ahead.
Somebody left.
Some people are dropping off, but that's okay. Yeah.
Anyway, interesting stuff. So yeah, my goal is to pursue Unity a bit here, and maybe it'll yield something fun in the way of a simulator. And I kind of thought, well, while I'm at it, you know, I might take some of the other stuff like the line following simulator stuff and incorporate it into Unity, although that's not really necessary. I guess really my goal would be more outdoor contest or even 6CAN, that sort of thing, and just see what I end up with. Is it a mess? Is it hard for people to mess with? because certainly when you try to take on everything in Unity, that's a big project. But maybe the idea is almost like a simple application, kind of like the line following simulator, really, where you just write a controller and you have a pretty simple thing you're doing. That's kind of the thing. I don't know.
Well, I'll tell you what, your line following simulator was amazing. I took it in when I ran the basic and the advanced. What I was doing is I was modeling an existing robot that I had, and then I was able to actually go in and see what, luckily I had done a lot of things right, but I had done some things that, could have been done a lot better. I could have squeezed out a lot of speed with just minor dimensional changes, and it was pretty amazing. I thought that was, that the insight that gave me about which things were really critical was definitely something I'd love to see in the next thing.
Cool.
Yeah.
So Ron,
Yes.
we look forward to your presentation on the Unity simulation. And then after that, for your cue, we can have you tie Unity into ROS, and then we'll just have it all covered.
Yeah.
All right, guys. Any other show and tells for the day, or any other topics we want to touch on?
I think, and I want to thank everybody again for the award. That really touched my heart. I appreciate it.
Well deserved, man. Well deserved. And again, a big round of applause for Jack. I mean, in just a few years, from knee-high to a grasshopper to driving his CoolBot along the golf course. That's pretty good, Jack. It's really inspiring. Really awesome.
Yeah, and it's cool that you followed so well. That's neat. It makes me kind of want to go back and if it's the stuff that I can remember, but it's really cool to see the evolution, and the drawings keep getting better and better, and everything. It's like, wow.
Thank you. Thanks for attending too. That was very nice.
Yep. So we'll get you a link, Jack, and you can share
All
it
right.
with interviewers, however it helps and whatnot. So all good.
All right. Thank you.
Cool.
With that, everybody, bid you a good rest of the weekend, and we will see you Tuesday night. Take care, build robots, have fun.
Cool. Thanks.
Bye.
See you guys. Thanks,
Bye.
Doug, for doing it too.